On section 2.6, we're going to be talking about formalizing relations and functions. And the question is, how can you tell what is a function? Very easy. X cannot repeat. Let me repeat that. X cannot repeat. And last time, X cannot repeat. What I'm talking about is that the X values cannot repeat themselves. If you see an X repeating on a graph, on a table, or in a set of ordered pairs, that tells you that it's not a function. Okay, so X cannot repeat. So let's go ahead and look at example 1 so you can see how this works. Alright, for problem number 1, identify functions using mapping diagrams. The first thing it says, identify domain and range of the relation. Second, represent the relation as a mapping diagram. And third, is the relation a function? So let's start first with domain. Okay, domain, and let's go ahead and write this down. Domain here domain is really all the X values. Okay, so let's look at all the X values for these set of ordered pairs for A. You have -2, 0, 4, and 5. So what we want to do is we want to show that the domain is, and what you're going to do is you're going to create a little bracket, and you're going to go from smallest to largest. Okay, you're going to start with -2. Then it's 0, followed by 4 and 5. At any point, if any of these values for X repeats, then don't write it twice, just write it once. So when you see domain, it's only going to show you one of the answers, one of the values. If they repeat it, it won't show it. It will only show it once. Now let's look at range. So now we're going to go ahead and look at the range. So the range, we have 0.5, 2.5, 6.5, and 2.5. So we're going to go ahead and say that the range is, well, those are going to be all your Y values. Okay, so the range is going to be, again, you want to go from smallest to largest. The smallest value is 0.5, followed by 2.5, 6.5, and if you notice, it repeats itself as 2.5, so we will only say it once. So we want to go from smallest to largest. The 2.5 repeats itself, so we only want to say it once. So we only write it once, and that's all you have to do. Okay, now the mapping. Now we're going to go ahead and do the mapping. For the mapping, we're going to draw two circles. Okay, one represents the domain, so we'll put domain. Let me use another color here. So we'll just write domain. And the other one's going to be the range. So we're going to go ahead and just copy these values down. -2, 0, 4, and 5. On this side, we're going to put 0.5, 2.5, 6.5. Okay, now what we want to do is connect these, the domain with the range. So the way we do that is we're going to use these values here and connect them with the points on the top. So -2 is going to connect with 0.5. So -2 connects with 0.5. Okay, 0 connects with 2.5. 4 connects with 6.5. And 5 connects with 2.5. So that's how you do a mapping. Okay? Now, the other question is the relation a function? Again, what I need you to do is look at the value of X. Here you have -2, 0, 4, and 5. The X does not repeat. Because the X is not repeating, we're going to go ahead and just say that X or in this case, because x does not repeat, we're going to say that this is a function. So the relation is a function. So this is a function. Okay, now let's look at B. For B, we're going to again look at all the x values. So we're going to go with all the x values. That's going to be your domain. Okay, domain is going to be all the values that are the x. So it's going to be 6, 4, 6, and 5. Always start with the smallest number. 4 is the smallest number. The next one is 5. The next one is 6. So there's your domain. Now we do the y values. The y values, that's your range. So now we're going to look at 5, 3, 4, and 8. Start with the smallest, the 3, followed by the 4, followed by 5, and then 8. Alright, so that's how you write domain and range. Now, we're going to go ahead and do the mapping. So for the mapping, we need 2 circles. And we need to show them as domain and range. And then we're going to write all the numbers that are from our domain here, 4, 5, and 6. And on this side, we're going to put all our range, 3, 4, 5, and 8. And then we connect. We look at our ordered pairs. 6 connects with 5. So 6 connects with 5. The next pair here, 4 and 3 are connected, the ordered pair, 4 and 3. So we go to 4, draw an arrow towards 3. The next ordered pair is 6 and 4. So 6 connects with 4. And then it's going to be 5 connects with 8. So 5 connects with 8. Alright, next thing is, what is the relation of function? So what you need to do is look at all these values and determine if x repeats itself. So let's look at x now. So here we have 6, 4, 6. So notice right here that the 6's right here are being repeated. Okay, remember, x cannot repeat. Because this did happen, we're going to go ahead that this is not a function. Okay, so that's how you can tell when it's a function. And really, guys, the most important thing is understand how to do domain and range. Domain is your x values, range is your y values, and then determine how it's not a function. It's not a function because the x is repeated, 6 and 6. Okay, all right, let's move on to problem number 2. Okay, for problem number 2, we're going to identify functions using tables. Decide whether the relation shown in the table defines a function. Again, a function cannot repeat the x. If it repeats the x, it's not a function. So let's look at the x values for A. You have 2, 3, 4, and 5. Notice they're all different. That's all you need to check. So therefore, we're going to go ahead and say that this one is a function. All right, let's look at the next one. You have 4, and then notice there's another 4 right there. As soon as you see that x is being repeated, okay, that's right there telling you that this is going to be a non-function or not a function. Okay, so that's how you can tell if it's a function. All right, that's all there is to this problem. Let's go on to the next problem. Okay, for problem 3, we're going to identify functions using the vertical line test. Is the relation a function? Use the vertical line test. All right, if you don't know what a vertical line test is, okay, you're going to draw a vertical line going straight up and down like this. Okay, you can use your pencil, you can use anything, but you want a straight line, vertical. If on the graph it touches more than one point, so if it touches a point and then somewhere down the line it touches another point, this is considered not a function. Okay, but if you have a straight line and it only touches one point, okay, then this is a function. Okay, so if it touches once, okay, so if it touches once, it's a function. It's not a function if it touches more than once. Okay, so that's what you're looking for. So anything more than one is not a function. So let's start with A. You have all these points. You need to identify whether it's a function. So what you want to do is just draw a nice vertical line. So we're going to go ahead and find if there's 2 points on a vertical line it touches. So here, that is okay. So that touches once. If it goes straight down, it doesn't touch. So that point is okay. But if I go to another point right here, notice that at this vertical line I'm touching for this graph A, there are 2 points that touch here and here. So the vertical line test fails. So since the vertical line test fails and it's touching more than once, we're going to go ahead and say that this is not a function. Alright, so this is an example where you have discrete or there's just points. But let's now do an example of a graph that is continuous. So if you notice this is curved, but if you do the vertical line test, anywhere on this graph, so if I draw it here, I draw it here, I draw it here, in this graph, everywhere it touches only once. It doesn't touch it anywhere other than at those points once. So therefore, since it touches once, we're going to go ahead and say that this is a function. Okay? Alright, so that's it. That is section 2.6. All you need to know is determine whether it's a function. You do a vertical line test by drawing a vertical line and touching to see if it touches once. If it touches once, it's a function. If it touches more than once, it's not a function. And the other thing is understand what is your domain, what is your range. And remember, the most important thing that I had told you earlier is, since this section is so easy, is x can't repeat, x can't repeat, x can't repeat. Okay, that's how you know it's a function. Okay, so we'll see you then tomorrow. If you have any questions, bring them up.